Next one is file structure. So as I told you, this microcontroller have two tools. You can generate the C code or C++ code. This is based on the configuration of the microcontroller. As a user, you define. You are the user. You define the pin configurations and peripherals configuration and so on. You are configuring the pins. For example, I want to use a specific pin for input. I want to use a specific pin for pin number 8 for input, pin number 9 for output, pin number 9 is for output, and pin number 10 is for ADC, and pin number 11 is for timer. So I configure the pins as a user according to my need. And then I generate the C code based on my configuration. So for that, we need a tool, separate tool, software tool. So this tool will have an interface. So we can just see and we can set up these things and we are generating the C code or C++. It's up to you. But mostly we prefer to use C because C is the best for embedded programming. So you are generating this in your PC, C code, and then you need a compiler. compiler. So compiler, what the compiler is doing, the compiler will help you to edit the C code. If there are any errors, then you can debug the code. And there are so many different types of the development, the code generating tools, and there are so many different types of compiling tools. These two are two different purpose we are using that for. Everything is software based. You are using in the PC or in your laptop. So why I am talking about this one. So once you generate this C code, there will be so many files. There will be plenty of files. For example, here you can see. So you will have so many files, and you should know what is the file structure. And some files are just only talking about headers, and some of them are just like talking about some global declarations and global definitions. So if you look at each file, then you will get really confused. It's not really important. So you have to only look at the main program. So you have to just open for example, the main.c. You just open this one in the compiler. Any compiler you can use. As I said, like maybe we can use Scale, Vision. So then you can just open and see this program, and then you can do some user-based programming, whatever you want. For example, you want to set up the timer, or you want to set up, you want to measure the data from some sensors. That data you want to feed to this microcontroller. So you can write whatever the program you want in this compiler, and then you can edit. It means you are changing the program, editing the program generated by this tool, and then you can compile it. And if you find the errors, then the tool will help you where are the errors and what should you do. Then you debug, and then finally you are loading this program into the microcontroller. So in the firmware, so you are just loading this program that is called embedded programming. So we are going to embed this software program into this microcontroller. Then the microcontroller will do whatever you want. So okay, I think we are talking into more about the application. We'll talk about that later. So right now we are in the file structure part. So once you generate the C code, it will generate so many files. Then you should know which file you should look at. So that's what I mentioned here. When reading source code, it's often easier to understand it if the reader is familiar with the structure of the code. And yes, you have to know or familiar with the structure of the code generated by this tool. And if you know the structure, of the application code, then it will be easy to understand where the peripheral initialization code, where interrupt handlers, and where you can write the application code and so on. So you should know the code generated by this tool, how to read the code, because based on your initialization and configuration, in the main program, each part will have something. So you will have the comment, for example, it will say the peripherals initialization, and then it will give some codes because it's generated by this tool, and then it will give some other description or comment, and then it will give the code. So you should just go through the program and then see where are which code belongs to what purpose. And then if you want to edit later, they will also give you some space for you, user codes begin, user code ends. So it means here you can type your program. So you can type whatever the application you want. For example, now you want to blink the LED. The LED means you know that, so light emitting diode. So you want to blink the LED, yellow LED or blue LED or red LED, whatever. So you want to blink the this is the yellow and this is blue. You want to blink this yellow LED for 5 seconds. You can write the coding for that. And you want to blink the blue LED for 10 seconds. So whatever you want to control some kind of servo motor, you want to control the water to your plant, you want to measure the temperature or whatever. So there are so many purposes you can write. So you should know how to read this C code generated by the tool. Then it will be easy. Before you read the code, you should know there are several files and which file you have to look at. So for example, here I have in the Nucleo board L476 I have used, and I generated some C code based on a specific configuration I made. So this is the real-time file structure. So here I have so many files. These are the source files, and this is including some header files. And in the source files, inside the source directory, I find main.c. This is the main program. So mostly you will go into this main.c and do some editing, some modifications. Okay, so it all starts with the structure of the source code generated with the STM32CubeMX. So I used the tool CubeMX, and of course this tool was developed by ST Microelectronics.